All right. Lesson 8.2 is graphing simple rational functions. Now, when we're dealing with rational functions, this is when we're going to actually, a rational function is a function in the form f of x equals p of x over q of x, where p of x and q of x are actually polynomials, so they're going to have variables in there, some exponents. The only criteria is that q of x, the bottom one here, cannot equal 0, okay? And the reason for it is, the reason that it can't equal 0 is because if I had some number, doesn't matter what the number is, but when we try to divide that out, 0 times what will give us 6? And you find out that there isn't anything. Nothing times 0 will actually give you 6. So that's why the bottom of the fraction can never be 0, okay? So let's go ahead and take a look at what a rational function would look like. This is actually the graph of y equals 1 over x. Okay? Now, these little blue things right here, those are called branches. Okay? Those are actually the graph. Okay? Now, remember when we said that 1 over x cannot be equal to 0. Okay? Because if x equals 0, for example, then I'm going to get 1 over 0. And it's the same thing we just did on the last one. 0 times, there isn't anything that you can take 0 times and get 1. So what happens is, that's why these graphs kind of look like, they're called hyperbolas. And that's why they they kind of get, they approach that 0 and then they kind of turn and go in the other direction. And that's because we have two lines and they just happen to be, on this one, they just happen to be the axes. That doesn't always case, and they're not always going to be the axis. Those will switch around. But those are called asymptotes. And an asymptote is a line that the graph will approach, but it will never touch. It'll get extremely close, but it'll never touch. Okay. So as you notice, this blue one here is approaching the y-axis, but it will not touch the y-axis. It'll get really, really close, but it won't touch it. Okay. And likewise, when it's coming down, it's getting really, really close to the x-axis, but it will not touch it, okay? And just like here, this one, as it approaches, is getting really close to the x-axis, but won't touch it. Getting also close to the y-axis, but will not touch it, okay? Now the question is, how do you actually find these asymptotes when you actually have a graph? So make sure you have the formula that's written down. Y equals a over x minus h plus k. Okay, so there are two asymptotes. The first one, which is x equals whatever the bottom of the fraction is right here. Okay, you just set it equal to 0, because remember, the bottom cannot equal 0. So in this example, if I wanted to find what the x one was, which would actually be the vertical, it's going to be, I take whatever the bottom of the fraction is, so x minus 1 equal to 0, and I just solve it for x. So I'm going to add 1. So I find out that my first asymptote, the vertical one, is x minus 1, or x equals 1. So I come on the x-axis, and I graph that line, y equals negative 1. Okay? So this would actually be my vertical asymptote. Okay? So the graph is going to get really close, but it's not going to touch it. Okay? The other one is just, this is the y equals, or the horizontal one. Okay, remember, this one's vertical, up and down, and this one's horizontal. Okay, so so in this case, since here's my plus 2, it's just going to be y equals 2. Make the graph, and then that would be my other asymptote. Okay. Now, as far as graphing the branches, to finish this problem out, what we would actually do is, okay, to graph it, you need to draw in your asymptotes. So remember, this asymptote was 1, and the other one was at y equals 2. Okay. So when you're actually finding out where the branch is going to go, because they could actually go in any of the 4 places on the side of these graphs, what you need to do is you need to pick 2 points to the right of the vertical asymptote and 2 points to the left of the asymptote. So remember this was x equals 1. So we're going to pick 2 and 3. So x could be 2, x could be 3. You're going to plug it in. Okay, so if we plug it in, let's find the first one. I'm going to get 3 over 2 minus 1 plus 2. Well, 3 over 1 plus 2, I get 3 plus 2, which gives me 5. And the other one, I'm going to get 3 over 3 minus 1 plus 2. You probably more than likely will get some fractions, but 3 over 2 is 1.5 or 1.5 plus 2. We're just trying to find out approximately where those graphs going to be. Okay? So we actually find out that it is at 5, 2, 5. So we're going to graph that point. 2, 1, 2, 3, 4, 5. And 2, and then 3. 1, 2, 3 and a half. And that'll give you some idea of how your branches need to be graphed, okay? And where they need to start, okay? So let's go ahead and do the next one. I'm going to go ahead and erase these so I got some room to work. So now we need to pick 2 points that are on the right of the asymptote. Oh, I'm sorry, on the left of the asymptote. So we're going to pick 0 and negative 1. 0 and negative 1. Okay? So if I pick 0, I'm going to get 3 over 0 minus 1 plus 2. Well, 3 over negative 1 plus 2 gives me a negative 3 plus 2, which actually gives me a negative 1. So 0, negative 1 is my first one. The other one, I get 3 over negative 1 minus 1 plus 2. So I get 3 over negative 2 plus 2. So I get negative 1.5 plus 2, which gives me a 0.5. So I get negative 1 and 0.5, okay? And then, so we graph those, and remember that just gives us an idea of where our branches are supposed to be, okay? So that's what the graph would look like. So go ahead and do the next example, y equals negative 1 over x minus 4 plus 3. This would be a good place to go ahead and pause it. That way you've got the directions, you've got the example, the one that we did, okay? All right, so example number 2, we're going to graph y equals negative 1 over x minus 4 plus 3. Okay, so remember the very first step that we need to do is we need to find our asymptotes. Okay, so remember to find the vertical one, we're going to do x minus 4 equals 0. Okay, since it's on the bottom of the fraction. So just add 4. So the first one we find out is x equals 4. 1, 2, 3, 4. So there's the first vertical asymptote. Okay, and remember to get our other one, it's just y equals 3 is our 1, 2, 3 horizontal asymptote. Okay, so that's what our asymptote is. Now, remember that the next step is that you need the vertical one, which is this x equals 4. We need to pick a couple of points that are greater than. So let's pick 5, and the next one would be 6. Okay, so if we plug those in, we're going to get negative 1 over 5 minus 4 plus 3. So negative 1 over 1 plus 3. So I get negative 1 plus 3, which gives me 2. Okay. And the next one I get negative 1 over 6 minus 4 plus 3. So negative 1 over 2 plus 3. That's a negative 1/2. So I get 0.5 plus 3 gives me 2.5. Okay, so 1, 2, 3, 4, 5. 1, 2. Let's change the color to blue. And then 6. 1, 2.5. Okay, so you find out that your asymptotes should look like this. Okay, and that's also going to give you a clue because more than likely your other branch is going to be up in this side. Okay. So I find that I get pick 2 more points that are less than. So I'm going to pick 3 and 2. Okay. And I get, so when I plug that in, let's erase these. I get -1 over 3 minus 4 plus 3. So -1 over -1 plus 3. So I get 1 plus 3, which is 4. So I get 3, 4. 1, 2, 3, 1, 2, 3, 4. And the next one I get 1 over 2 minus 4 plus 3. So 1 over -2 plus 3. Oh, this is a -1. So it's negative over negative, so I get 1/2 plus 3, which is 3 1/2. Okay, so 2, 1, 2, 3 1/2. So there's what our asymptote needs to look like. Okay, all right. And the last example. Now, if you'll notice, this one, when you're graphing your asymptotes, you get, remember you got to do the bottom. So 2x minus 4 equals 0. Add 4. So 2x equals 4. Divide by 2. X equals 2. And then, since there's no plus or minus over here, then your y is just going to equal 0. Okay, so let's go ahead and graph those two. So I get x is 2. We've been doing our asymptotes in red, so let's just continue that trend. Oops. So there's x equals 2. And my other asymptote is right along the x-axis, okay, where y is 0. Now, just like what we've been doing before, we need to pick 2 points that are greater than 2. So we're going to pick 3 and 4. Find our y value. So I get 3 plus 1 over 2 times 4 is 8. I'm sorry, 2 times 3 is 6. So 6 minus 4. So 4 over 2. And that gives me 2. To do the 4, it's going to be 4 plus 1 over 2 times 4 is 8. 8 minus 4. So I get 5 over 4. Okay, which is 1.25. Okay, when I'm graphing those. So I get 3, 2, 1, 2, 3, 2. And then I get 4, 3, 4. Oops. 1, 2, 3, 4. 1 and about 2. So, okay. So then we need to do, remember we need to do the other two sides to find out where those branches are going to end up. So I need to pick values that are less than. So I'm going to pick 1 and 0 for my x. So 1 plus 1 over 2 times 1 is 2. 2 minus 4. So I get 2 over -2. So I find that one's -1. Next one is 0 plus 1 over 2 times 0 is 0 minus 4. So I get 1 over -4, which is -0.25. So 1, -1. 0, -0.25. So our branches are going to look like this. Okay. All right. Well, that completes graphing 8.2, graphing rational functions. So go ahead and do some of the practice problems before moving on to the quick check.